You know, your CI/CD pipeline, it's the engine that powers all your development. But what happens when that engine has a hidden flaw? So today, we're going to talk about how to transform that potential security risk into your company's most trusted asset, all within your GCP environment.
Okay, let's kick things off with a story I'm pretty sure we've all lived through. The dev team is flying, the code is ready to ship, and then, screech! Everything grinds to a halt at the security review. It's slow, it's manual, and it becomes this huge bottleneck right when you need to move fastest.
And this slide just nails it, right? It shows the two completely different worlds. On the left, you've got the old way, security last, where it's this final, painful gatekeeper. It's slow, it causes all this friction, and worst of all, it finds problems when they are the most expensive and annoying to fix. But on the right, that's where we want to be, security integrated. It's all about automated checks, super fast feedback, and making security a team sport, catching issues early on.
And this all comes down to a super important idea called shift-left security. It's a really simple concept, but it's incredibly powerful. Instead of thinking of security as the final exam, you're building it into every single step of the process. Think of it less like adding more work for developers and more like giving them security superpowers to find and fix issues on the spot, saving days of painful rework down the line.
Okay, so theory is great, but how do we actually do this? Let's build out a practical map that shows exactly where you can plug these security checks into your own CI/CD pipeline.
So most CI/CD pipelines, yours included, probably follow these 4 basic steps, right? A developer commits some code, that code gets built into something like a container image, that artifact gets tested, and finally, it gets deployed. We're going to use this as our roadmap for placing our security checks.
So, our very first chance to catch something is right here. At the code stage, the second a developer hits commit. We can automatically run checks for code quality, we can scan for secrets to make sure nobody accidentally checked in an API key, and we can do dependency scanning, which is also called software composition analysis, or SCA, to check our open source libraries for any known issues. This is your fastest, earliest line of defense.
Okay, now check this out. We're shifting gears a bit. We're not looking at the raw code anymore. We're actually inspecting the thing we just built, the container image itself. This is where we scan for vulnerabilities in the operating system or other packages inside the container. And we can even digitally sign the artifact here, which is like putting a tamper-proof seal on it, proving it's a trusted build.
And then, as we get closer to going live, in the test and deploy stages, the checks get even smarter. We can run something called Dynamic Application Security Testing, or DAST, which actually pokes and prods the live application to find vulnerabilities. And if you're using infrastructure as code, this is the perfect time to automatically check that your cloud configurations match your company policies before you deploy.
Okay, all of that sounds great on a slide, right? But what does it actually feel like when one of these automated security gates catches something and slams shut? Let's just walk through a quick story.
So picture this, deep inside your pipeline, you've got this one simple command running automatically every single time a new container image gets built. It's just a clean, simple check that happens in the background, no big deal.
The pipeline's just doing its thing, chugging along, it runs the scan, and bam, it finds something nasty, a critical vulnerability. Now what?
Well, the first thing that happens is you get a report just like this. And the key thing here is that it's not vague at all, it's super specific. It says, hey, there's a critical vulnerability in this libcommon package, and guess what? There's a fix available. It's totally actionable.
And this is the moment where everything changes. The pipeline doesn't send an email and hope someone reads it. It doesn't open a ticket. It takes immediate, decisive action. The build fails right then and there. The deployment is completely blocked, stopping that vulnerability in its tracks long before it ever gets near production.
Now, I know what you might be thinking. A blocked deployment sounds bad, like a failure, but it's actually the complete opposite. This isn't about blaming a developer, it's about empowering the whole team with instant, clear, and actionable feedback.
And this, right here, is the whole point. This is why this stuff matters so much. The old way, you'd find out about a security bug days later. You'd have to stop everything, switch your brain back to code you wrote last week. It's just painful. It creates a blame culture. But with this integrated, fast feedback, the developer finds out in minutes. They can fix it right then and there while it's all fresh in their mind. Security stops being a blocker and starts being a partner.
Okay, so where do you even start with all this?
Let's boil it all down to a practical checklist, a baseline of security gates you can implement in your GCP pipeline, like today.
This is it. Seriously, if you're looking for a place to start, this is a fantastic checklist for pretty much any team. Set up these 4 automated gates. Analyze your source code, scan all your dependencies, scan the container images themselves using something like Google's own artifact analysis, and validate your infrastructure policies. Just doing these 4 things will massively improve your security posture.
So let's wrap up with this one last question for you. In today's world, nearly everyone has an automated pipeline to ship code fast. That part's not special anymore. The real question isn't just, are you fast? It's, are you safe? Because at the end of the day, automation gets you speed, for sure. But integrated security is what makes sure that speed doesn't drive you right off a cliff.